Hi there, everyone. In this video, we're going to talk about the complement rule. The complement rule is a very important rule in probability that allows us to compute the probability of an event by instead computing the probability of its complement. So let's take a look. The complement of an event is denoted by A. So if the event is named A, then the complement is denoted A with a superscript C. If the event was E, the complement would be E with a superscript C. Right? So that we use the superscript C to denote a complement. And what does that represent? It represents all of the outcomes that aren't in A. And so it's the opposite of A. So for instance, let's just jump down to this example. We roll a fair six-sided die. Find the probability of not obtaining a 5. Okay, this is the probability of not obtaining a 5. That's the opposite of obtaining a 5. It's looking at all the possibilities except a 5. So we are looking at the complement of rolling a 5. Okay, so let's see what this rule says. It says that if I take the probability of an event and the probability of its complement and I add them together, I always get 1. Now, why is that? Well, if we think about all the possible things you can get on a die roll, you can get 1, 2, 3, 4, 5, or 6, right? And so if you roll a 5, right, that's an event. And the complement of that event is anything else. So it's 1, 2, 3, 4, or 6. Now we know the probability of getting any number is 1. You're guaranteed to roll something on a die. And so if you break apart that into two pieces, 1 through 4 and a 6, and then a 5, then you see that they have to add to 1, because if you combine them, you get everything. And so that's where this rule comes from. The sum of the probability of an event and its complement have to add to 1. You can use a little bit of algebra on this. If you just subtract the probability of the complement from both sides, you get this relationship. And if you subtract the probability of A from both sides, you get this relationship. And all these relationships are very, very useful, because sometimes it's easier to compute the probability of a complement than it is to compute the probability of the event itself. And if you can do that, that's great, because then you can just use this relationship to get the probability that you want. So for instance, find the probability of not obtaining a 5. So what I'll do to compute this is I'll find the probability of obtaining a 5. So the probability of rolling a 5 on a fair six-sided die is, well, it's one possibility out of 6, so it's 1/6. So the probability of not getting a 5 would be 1 minus 1/6, and that would be 5/6. So we've used the complement rule to compute this probability. Now I wrote not 5. If I called my event A, rolling a 5, this would be A complement, right? But this is just a different way to write it. Okay, let's look at this next one. Toss 4 fair coins. Find the probability of getting at least 1 head. All right, so this is one of the cases where it's much easier to compute the probability of the complement than the event itself. Getting at least 1 head, there's lots of ways to do that. You could roll heads, tails, tails, tails. You could roll heads, heads, tails, tails. You could roll heads, tails, heads, tails. There's lots and lots of different ways to do that. So instead of trying to find that probability directly, what we'll do is we'll compute the probability of the complement of this event. All right, so let's let A be at least 1 head. All right, what's the complement of this event? The complement of getting at least 1 head, the opposite of this, is to get no heads at all. 0 heads. There's only one way that this can happen. A complement is the same as getting all tails. Tail, 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 tail. Okay, now that's something we can compute the probability of. How would we compute this probability? The probability of getting tail, 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 tails. Well, there's only one way if you toss a coin 4 times that this can happen, right? You have to get exactly this result. How many possible outcomes are there when you toss a coin 4 times, or 4 fair coins? Well, there's 2 possibilities for the first coin, 2 possibilities for the second coin, 2 possibilities for the third, and 2 possibilities for the fourth. So there are 2 times 2 times 2 times 2. That's 16 total possibilities. So the probability of getting 4 tails is 1 out of 16. Now, I want the probability of A of getting at least 1 heads. So this is where I use the complement rule. The probability of A is 1 minus the probability of its complement, which we said was 1/16. 1 minus 1/16 is 15/16. And there's my answer. Okay, let's look at this next one. Toss a single coin repeatedly until heads. Find the probability that it takes at least 2 tosses. Well, this is rather complicated because there's a lot of ways that it could take at least 2 tosses. It could take exactly 2 tosses, or exactly 3, or exactly 4, or 5, or 6, or 7, or a number of tosses greater than or equal to 2. There's an infinite number of possibilities that constitute this event. So computing this probability would involve considering an infinite number of possibilities. That's crazy, right? That's really hard. So this is a situation, again, where we should think about the complement rule. So if I let A denote the event of it taking at least 2 tosses, what's the complement of A? The complement of A is that it takes, well, the opposite of this. It doesn't take 2 or 3 or 4 or 5 or 6. It takes exactly 1. That's the opposite of this event. If this doesn't happen, that means this does happen, and vice versa. If this doesn't happen, that means this does happen, right? So these are complements. And so what we'll do is we'll compute the probability of the complement. The probability of exactly 1 toss to get heads, well, what's the probability of getting heads in exactly 1 toss? Well, it's a coin, so it's 50-50, it's 1/2. And so if I want to know the probability of it taking at least 2 tosses, I know from the complement rule that is equal to 1 minus the probability of the complement. That is 1 minus 1/2. That is exactly 1/2. So even though this is an event with an infinite number of possibilities, we can get at it very simply by using the complement rule.